Hello, everyone, and welcome to today's QA Wolf Conversation, AI Prompt Evaluation Beyond Golden Datasets. I'm your host, Caleb Masters, and over the next 30 or so minutes, we'll be talking about how QA Wolf decided to take an innovative approach to evaluating the prompts for our AI. But before we go any further, I want to welcome a pair of very special guests. They are our subject matter experts and the real star of today's presentation. First up, it's always a pleasure to welcome the QA Wolf Senior Director of AI, Nishant Shukla. Nishant, welcome.
Hey, Caleb. Thank you for having me.
Nishant, always a great time talking with you. I'm also thrilled to be joined by another very special guest. He's the CEO and co-founder of Helicone, Justin Torre. Justin, welcome.
Thanks, Caleb. Happy to be here.
Awesome. Well, gentlemen, we have so much to cover. But before we dive into any of the details, I wanted to give everyone a quick glimpse at what all we'll be covering today. So first up, we're going to be talking about why evaluating prompts has been so challenging in the past. Before we move on to our second section, where we'll talk about the pros and cons of using the Golden Dataset, which has, up to this point, really been the best practice or wisdom on solving for this challenge. And then lastly, we'll talk about how using random sampling creates more effective prompts in the long run. Let's jump right into this first topic, though. In the rapidly evolving world of AI, speed and accuracy are essential. I think that goes without saying for anyone who's tuning in today. But using the right prompts is really one of the most important ways to stay ahead of industry developments and, of course, the competition. But maybe you might be asking yourself, how do I determine the most effective prompts for the task at hand? Well, this has been a question that a number of engineers working in AI across industries have been trying to tackle head on. So, Justin, this is part of the reason we brought you on today, given your expertise in prompt evaluation. I want to get your perspective, just looking, at a broader view when it comes to prompts for AI. How do you and the team at Helicone define a good prompt?
Yeah, so in order to find a good prompt, I first ask our users to break down prompts into the basic components. So every single prompt can be broken down into two components. We have variables and tasks. Variables are what you want the AI to work with, while tasks are how you want the AI to work with it. So in the most simplest case, I'm sure a lot of you folks that are watching this have done this, is copy an email into ChatGPT and ask it to sound more professional. So in this case, the variable is the email itself, while the task is asking the LLM to sound more professional. This structure of pairing the task and variable is the foundation for creating any complex agentic workflow that companies like QA Wolf use. The actual inputs themselves might be tests, results, code, like database searches, vector searches, and the tasks might be executing a change, finding a flaky test, all those types of things. So going back to your question, what makes a good prompt? I would say it's finding high quality input variables and being able to convey to the LLM a well-defined task that you want to execute. So just to reiterate, is finding high quality variables and defining a task well enough for the LLM to understand.
All right. Well, Justin, hey, I really appreciate you providing a little bit of a clear definition. That is really the goal we're aiming for, is having those good prompts that really to make the most efficient use of the AI's energies there. Now, before we dig into the specifics behind how QA will solve for this challenge, Justin, I want to turn it back to you just to get a better look at what all is going on industry-wide. Why has evaluating prompts for large language models historically been a challenge, especially for some of your clients?
Yeah, so no matter, I mentioned before, developing a good prompt requires both high quality variables and a well-defined task. No matter how well-defined your task is, AI and ML, by its very nature, will always return some randomized output. With only in the past 2 years, we've seen like the rise of the prompt engineer kind of take fold and sort of cement itself as a real title. And with the prompt engineer will quickly iterate on that prompt in real time to hopefully try to reduce the prompts or the LLM's randomness. So honing down what that task definition is. But the problem, this like sort of iterative loop, is you need a human to be monitoring these outputs, because these outputs may have multiple valid answers. They're usually subjective, so you can't really have like an objective analysis to say this like 2 plus 2 is always 4. That's not the type of things we're looking at. We're looking at very subjective outputs that these LLMs are giving us.
All right. Well, I appreciate you providing a little more context on the challenge here, which is trying to figure out how to predict or control randomness in a lot of ways. Now, Nishant, I want to turn it over to you here to understand, what are the challenges QA Wolf has faced as it relates to prompt evaluation. I'm sure there's some overlap in terms of the larger problem, but also in the business of end-to-end testing here at QA Wolf, I'm sure there are also some unique challenges as well. So maybe you can talk with me about the challenges of prompt evaluation in QA Wolf. What does this look like in the tests that we run for QA Wolf clients with our AI?
Yeah, that's a good question, Caleb. What I loved about Justin's example with the make me sound more professional prompt is that, first of all, I think I'm guilty of that. I've used that for some of our Slack messages, but also that it really shows you that what, as Justin said, it's a randomized type of output. It's flaky. If you're creating assertions for that, you're going to have a difficult time really nailing down a good way to define what is the expected value of that. At QA Wolf, what kind of makes it even more challenging for us is the amount of prompts we have and how frequently we evaluate them for regression tests. For example, we have hundreds of prompts that we run every night to check for regressions and make sure that they still adapt to the new inputs coming in production. So the volume really adds this new complexity on top of the flakiness. Not only are these prompts flaky, but we would like to run them many times, many times a day, which means we have to deal with the fact that running prompts is slow and also expensive. The costs add up, the time adds up. It's just a much bigger problem here.
Right. So again, scale being a key challenge from what I just heard there. And Justin, I want to turn it back to you again, given your industry expertise here. What has been the conventional wisdom on solving for prompt evaluation?
Yeah, so a lot of folks that are using LLMs kind of come from a more traditional ML background, and they're using traditional ML approaches, which is go and generate your golden data set and continue to run evaluations against this golden data set. So these are usually meticulously handcrafted results or examples that they see in the real world, and they generate a data set. The example I like to give is we have one customer creating a bot to review pull requests. So what they do is they go on GitHub, they find the top projects, like React is one of the top projects, and then they grab all of the pull request data, including those reviews. And now that is their golden data set that they're trying to map their LLM to act like, for example.
Right. No, I appreciate you providing that example. And I guess sort of my follow-up in terms of looking at the pros and cons of the golden data set. Clearly, there's a number of reasons people might be sticking with it. Maybe you can elaborate here, at least in your experience, Justin. Why have so many teams stuck with this approach when developing their AI?
Yeah, it's because it's usually extremely high quality data. Like in the case of taking the top GitHub repos, you usually know that these are high, like senior engineers that are generating these results that we can rely on. And usually, depending on what that data source is, you can grab like consistent data formatting, usually some consistency within a particular like semantic or latent space, for example. You could also have like strict control over the data quality. So you could add manual reviewers to go in and label the data, filter data, stuff like that.
Right. So, I mean, it sounds like there are some clear advantages, but, one thing I just want to, posit, and this goes for anything in tech, I think is, both of you know, and also just people watching, as things go in tech, what worked best yesterday might not work best today, or at least not there without there being some trade-offs to consider. So when determining how to best assess our prompts, the prompts for our AI, we both weighed the pros and the cons of the golden data set with industry experts like Justin here. So Nishant, maybe you can walk me through it. Why did the QA Wolf team decide not to use the golden data set for our AI prompts?
Yeah, it's another great question. At QA Wolf, we have hundreds of prompts, and we change and update our prompts very frequently. I'd be lying to say that we've discovered the perfect prompt for a specific agent, or we have this multi-agent system where each agent has its own prompt. So there's a lot of improvements made almost daily to each one of those prompts, and we still haven't nailed down the perfect prompt yet. So if we haven't nailed down the prompt, then we aren't really ready to pick a golden data set to test that prompt, because by the time we've designed the golden data set, it's going to be outdated. The prompt has already changed, and we're still improving. We're still learning from production data. We're changing the prompt way too frequently to lock in a golden data set. So that's one of the biggest challenges, is just the maintenance cost involved for us. Another big challenge is it's the golden data set. It might not generalize to real world scenarios, especially in our case where our input is massive. An example of input to our prompts could be the HTML of the page or all the playwright code that's testing a workflow. That code could be massive. The HTML could be massive. If we are generating or manually creating a golden data set, then we risk ourselves not generalizing to real world scenarios, because we might be creating toy examples. We might be creating simplified versions of the inputs just to test things out. But when it comes to production data, we realize actually the real world is a lot hairier. And so getting snapshots of the real world to test becomes way more important. So that that's kind of one of the risks with a golden data set, is that generalization factor.
Right. And I appreciate, talking about the sort of the often hairy nature, or the tough to nail down nature of the difference between what the data is telling you in the test environment versus the real world scenarios that you're looking at. Very important distinction and challenge we have here at QA Wolf. Now, Justin, I want to turn it back to you here. I mean, hearing what Nishant's walked us through and sort of the challenges and reasons we did not use the golden data set at QA Wolf, what are some of the other pain points that you've seen with golden data sets and that approach more broadly through your work at Helicone?
Yeah, I mean, Nishant touched on a bunch of them. I really liked how he said calling it a toy example. I mean, that resonates a lot, where a lot of folks use golden data sets to sort of build an MVP. But once you get something in production, your prompt is constantly changing and stuff like that. I think just to reiterate, we definitely see a lot of overfitting happening, where not just with prompt testing, but also for fine tuning. If folks are trying to generate golden data sets to fine tune a model or run prompt evaluations against, you end up nudging that model closer to that sort of like semantic reasoning of whatever data set you're using. So in the example we gave earlier, it's a really good Torre project for having PRs that sound like engineers that might know the React code base really well. But if you want to grab that data set, run those examples, and like kind of shove your prompt and model towards those examples, it might not work for a more generalized other GitHub repo. So you end up getting something that is maybe too focused on a fixed benchmark, and it's preventing it to adapt in various conditions. So that's one piece that Nishant touched on a lot. The other piece is like sort of keeping it updated. So one of the benefits of sort of ditching this golden data set approach is that with golden data sets, you have like usually static, outdated data, and maintaining a golden data set is very expensive. So if you want to constantly grab the latest like keep grabbing like refresh data for whatever use case is, it's going to be really hard. And also getting it to shoehorn into those prompts is going to be very hard as well. Like the prompt structure is always changing. The types of inputs are always changing depending on your like application process. So that's one big thing as well. And lastly, is potential for, again, this relates to the overfitting, but a common phrase is inherent bias. So inherent bias comes in a bunch of different forms. You can see this where I touched on this with the PRs. You might make it sound more senior, where your product is actually for our junior developers, for example. That's like one inherent bias, but we can see this in all over ML, which is it might end up skewing the outcome of the model to the inputs that are curated for the data set. More classically, we've seen this a lot in the news with like ChatGPT or Stable Diffusion sort of having these internal biases.
All right, I appreciate you walking us through a number of unique challenges there, or at least considerations that people should have when thinking about, taking that golden data set approach. At the end of the day, it sounds like the maintenance cost, the lack of flexibility, and those scaling challenges, they really made the golden data set too rigid for QA Wolf's goals and desire to stay fast and accurate for our customers. And you mentioned overfitting. I can even see how overfitting could be a challenge for running automated tests specifically. The industries and applications that we serve are so vastly different. You really need a solution that's able to keep up with the unique use case for each one of our customers. And that is why we've instead decided to take a better, more innovative approach using random sampling. Now, we're going to see exactly what that looks like in action here in a moment. But first, Nishant, I wanted to turn it over to you, and maybe you could elaborate here for me. What do we mean when we say random sampling in the context of prompt evaluation?
Sure. So we talked about overfitting and biases, and that was relevant because when constructing a golden data set, you risk overfitting your evaluation on whatever that golden data set contains. But what if you could instead bias towards real world production data, or overfit to that, or at least fit closer to that, so that everything you're evaluating is a better reflection of reality instead of a hopeful, fingers crossed reflection of reality. And that's this idea of random sampling, where sampling is just the art of doing more with less. Instead of using all of the production sessions as your evaluation benchmark, that's going to be too difficult because there's too many of them. In the order of millions, it'll be difficult to traverse that and evaluate that because it's slow and very costly. So sampling is the art of hand picking a couple, or automatically picking just a handful of examples in production and evaluating against that small handful instead. Random sampling is a strategy of sampling where you randomly pick fairly with a fair random coin a couple items in production. There's other sampling methods too, some better than others. Random sampling is one of the simplest approaches, but also has the advantages of being fair to give each session in production an equal opportunity of being included into your evaluation benchmark.
All right. Well, I appreciate you providing that definition and just sort of elaborating on exactly what that entails versus that golden data set. What advantages has random sampling provided QA Wolf over the more common golden data set approach?
For us, random sampling has definitely sped up our ability to make changes to the agents, which has been great because now we're able to quickly check whether a change in the behavior of an agent by, for example, a prompt change is acceptable or not, or whether it causes a regression or not. It just allows us to move quicker to make these changes and improvements, and instead of having to wait for a deeper evaluation or risk a mistake in production, we can now feel more confident, just, sleep well at night knowing that it'll work.
Awesome. A good night's sleep, always worthwhile. That peace of mind is really valuable. Now, Justin, I want to turn it back to you here for a moment because earlier, I think Nishant mentioned, you might have mentioned as well, earlier we mentioned how evaluation data often fails to fully represent the variability of real world data. So how did the Helicone team work with QA Wolf to solve for the gap between evaluation data and the real world scenarios through random sampling?
Yeah, thanks for the question. So I think it's important to reiterate the points I was making earlier, where we always want high quality outputs and a well-defined task. So random sampling helps with getting those quality inputs or those quality variables up to date and close to real world data as possible. So all of the data comes into Helicone. We log every single request in this in Helicone, which is like this highly scalable infrastructure that supports all the multimodal use cases for QA Wolf. We manage all of their prompts and variables within this lightweight SDK that lives in their code. And then this allows us to randomly sample those input variables from their production data and then use that in some sort of experimentation. And then this experimentation is how we sort of have the engineers iterate towards this well-defined task. So the random sampling fixes the problem to generate high-quality inputs because this is real-world production data. And then for getting the well-defined task, we do this through experimentation. There really is no silver bullet for getting this well-defined task. Like the QA Wolf engineers have done an incredible job at defining like multiple page long prompts that sort of take in these inputs and do some behavior. But the real way you get a well-defined task is you kind of do it through evolution. So many different generations of iterating through this prompt. I think Nishant mentioned he's iterating his prompt almost every day. And as you're iterating and changing your prompt over time, it'll never reach perfection, but it'll definitely converge to perfection. And you're just going to constantly keep iterating on those tasks through experimentation, but you still need those high quality inputs. So this is how we end up sort of closing that gap, as you mentioned, Caleb.
Thanks so much for giving us that overview. But I actually want to take it a step further. I want to see exactly what QA Wolf and Helicone looks like in action. So I understand you brought a demo here for us today. So at this point, I'll go ahead and pass the microphone over to you. So if you could walk us through the QA Wolf use of the Helicone platform today.
Yeah, so I'm super excited to show an example project that I set up that simulates a workflow that like QA Wolf would typically have. So first thing I want to note is Helicone tracks all of your production data that we're going to be using for random sampling. So every call that would go to the LLM is tracked within Helicone. If it's a multimodal call, the images will be tracked. All the inputs and variables and the actual prompts are tracked as well. So here is an example request that we're looking at. It's a full page, and we're trying to find the interactive elements within this page. And the example we're going to be looking at is, let's say a teammate is sending us a session saying there is some weird behavior in this session. One of the buttons is not getting clicked, for example. He mentions that the eval page is throwing an error. So we can go ahead and look at this session, which is multiple LLM calls, and we can go ahead and look at the eval page step and see the request within this particular step in this agentic flow. And we can look at the particular LLM call that is finding the interactive elements and sort of do like this human evaluator to say, okay, is it actually detecting the buttons correct? Now, it's detecting the button correct here, but the main issue is that it's detecting button as child. So we're going to go ahead and head over to the prompt itself and look at what the prompt, see if we can iterate on the prompt. So we're looking at the prompt, and let's find the evals example and let's put that in here. So the prompt is a very classic prompt. So we're saying, like, as a QA engineer, detect all the elements on the following page, and then we give it the contents of the page. But we're not really giving any other instructions because we don't want to maybe like overfit it. But we do see it is returning the button as child. So we kind of have an idea how to fix this. Let's go ahead and create an experiment here to iterate on the prompt. And as we mentioned earlier, we want high quality inputs or high quality variables. So we're going to randomly sample our data. So right now we're randomly sampling 5 requests. that is plucked from production, and we're going to go ahead and put that directly into our workspace to iterate and create a new task or a new prompt to use these inputs to fix that as child bug that we saw in production. So one of the beautiful things that just happened here is all of the inputs from production were added to our workspace, as well as all of the outputs that we got from the LLM from that production use case. So I'm creating a new experiment to fix that as child use case. We're saying, hey, if a button is as child, don't return the button, but actually return the child element itself. We're going to save that prompt, and we're going to go ahead and run that particular task against the inputs that we randomly sampled from production. And then what we're going to do is we're going to compare, saying, hey, with this change that I'm highlighting right here, this added text, can we see the output from this experiment compared with the production output to make sure that we're not having any regressions and it's fixing our new case. So let's scroll down to one of the examples that provides the as child as the production use case. So in this production use case, we have button as child, and it's actually returning the child component, which is the link here. So this looks like it's behaving correctly. And we can sort of zoom out a little bit right here and see, okay, the other requests or the other elements that are being detected in this page might be sufficient, just kind of doing like a human eval here. But the main thing that we're looking for is the as child was fixed. And what we can do now is say, hey, we have this randomly sampled production data. We have these two outputs of real world production outputs, but then this sort of like sandbox test environment. We can take this link for this experiment and we can send it to our team saying, hey, I think we need to change prompt the interactive element detector prompt to add this extra line to account for the as child, and then we can attach that this session link to our pull request, for example.
Awesome. Excellent work, Justin. Thanks so much for showing us how random sampling works through Helicone at QA Wolf. Nishant, that was a really cool demo that Justin just showed us, but maybe you could provide a little more context on the impact that we're seeing here. What improvements and outcomes have you seen using this random sampling method at QA Wolf?
Yeah, let me go into a concrete example. At QA Wolf, we are using AI for test creation and test maintenance. So within test creation, one thing that I've experienced recently where random sampling helped a lot was our QA engineers at QA Wolf are changing and adapting the way they write their playwright code, whether it's through page object model or other techniques that are being introduced slowly. And as new techniques or new commenting styles or new coding conventions appear, we're now able to automatically include them in our evaluations because of random sampling, because we're randomly picking from recent production use cases, and we don't have to cater or really curate a specific golden data set. We're able to just adapt. This real-world generalization is awesome. And it also helps reduce that bias to outdated data. Now we're always looking at fresh data coming in. This allows the agents to adapt to this dynamic data, and it's also just super helpful for scalability and cost effectiveness. So all of this, it really boils down to us iterating quickly. We're able to change the behavior of our multi-agent system to adapt to real-world situations in just a faster iteration cycle.
Very cool. So again, we were talking about the speed, accuracy, and flexibility, and also scalability. The speed enables QA Wolf team to grow and experiment at scale. So Justin, I want to turn it back to you here. I mean, how do these compare to other benchmarks that you've seen or developed across industries?
Yeah, I would say QA Wolf is definitely ahead of the curve, like in many of the industries that we've seen. They're always on top of the latest trends. So we'd love to see how QA Wolf is kind of leading the charge here. One thing that I want to kind of touch on is that what we're trying to focus on at Helicone is we want to sort of pave the path for this new paradigm of evaluations for this new like AI ML workflow that's using LLMs. And the way that we do this is LLMs are now being used in production. And the big question is, when you're creating a GitHub PR, what does that future PR look like? Helicone wants to like pave the path for what that future GitHub PR looks like when iterating on LLMs because of this non-deterministic behavior. So a lot of these other benchmarking tools focus on generating data sets, more traditional ML workflows, whereas I think we're ready for a paradigm shift that puts an emphasis on production data and having teams iterate on tasks that can iterate on the task definitions of the prompts and have those prompts converge to some perfection, as we mentioned earlier. So we're focused more on monitoring production data, real world data, and using that data for prompt iteration and evaluations.
All right. Well, thanks again for elaborating on that. It sounds like, again, QA Wolf is sort of leading the charge in terms of, using that production data. Now, the tech that we've talked about today, of course, is very impressive, but ultimately what's most important is how we're using this tech here at QA Wolf. And most importantly, how we're using it to create better end-to-end tests for our customers. Everything that we've been talking about today is in service of our ultimate goal of achieving 80+% end-to-end test coverage for our customers. So Nishant, bring us home here. Maybe you can walk me through it exactly. How has the enhanced prompt evaluation helped us better serve QA Wolf customers?
Now the multi-agent system adapts quickly to changes, which is really great for when a customer website or UI changes, or when a new standard for testing is introduced. It doesn't take as long for the AI to keep up with all the changes. As Justin mentioned, these PR reviews that we do to change the prompt to then eventually get that code merged into main and then deployed into production, that process, it used to suck, but now it's just a lot easier. We're able to attach a prompt evaluation history from Helicone into the PR review and just say, look, trust it. I've randomly sampled a couple of production data through this new variation I wanted on the prompt, and you can believe that because it passed the evaluation, it's trustworthy, and just go ahead and approve that PR and merge it in. We need to ship this in production so we can keep up to date and really make an impact in the real world instead of just having to be stuck in development.
Right. Well, again, I know that's always an exciting innovation, and I think we could all keep talking about this for at least another hour. But unfortunately, we are out of time for today. So, Justin and Sean, I appreciate you joining today to share a little bit more about your team's work as it relates to prompt evaluation for the QA Wolf AI. Now, before we close out today, I did want to share a little more information with everyone who's tuning in regarding the multi-agent AI that Nishant and team are working with. So here at QA Wolf, we are revolutionizing software quality assurance with results-based end-to-end test automation. And by aligning incentives with customer success and leveraging the cutting-edge AI tools like we talked about today, QA Wolf is able to deliver unprecedented levels of test coverage and accelerate software development cycles. QA Wolf's multi-agent AI was built under the principle that humans need to be in the loop to deliver trustworthy and efficient results. Trustworthy results are the foundation and bedrock of everything we're doing here in QA. If you'd like to learn a little bit more or see what QA Wolf AI looks like in action, you can head on over to qawolf.com/AI and request a demo today. Justin, it's been such a pleasure. Thank you so much for joining us today to talk with us about prompt evaluation.
Thank you so much, Caleb and Nishant. I really had a good time.
Likewise. You're welcome back anytime. And Nishant, I hope it goes without saying that it's always a pleasure to get an update on all the cool things you and the team have been working on.
Of course. Thank you so much.
And for everyone tuning in, this has been Caleb, Nishant, and Justin joining you from the Wolf Den. For more conversations like these, you can head on over to our podcast, Wolfed. You can find that wherever you search for your podcast, or find us at qawolf.com. Thank you so much for joining us, and have a great day.